So this is scene 8. There's not a great deal going off in this scene really. We've got, let's look from the side of this asteroid, this sphere here, which has got a volume material applied to it that's supposed to be a nebula or something like that that I've randomly created. We've got this sun glow which has been taken from that sun glow, which is part of this sun assembly that gives this light source here. That's one of the light sources in the scene. I think, let's have a look, we've got the sun as the other darker brown light source in the scene. Atmospherically we've got some glowing stars, and in the background somewhere from the camera view we've got a star field, and that is associated somewhere in the region of where this planet is, but it doesn't matter because it's far enough behind not to cause a problem. So let's bite the bullet and have a look at this nebula effect created with a volumetric material. So I'm just going to shrink that down so we can see what it looks like there on a smaller scale. In fact, what I shall do is select the inverse and just hide everything else, hide and lock everything else so it doesn't interfere with what we're doing. Get hold of this sphere, pop it in the middle, enlarge it a bit, and we'll start talking about phase again. So in this sphere, it's a volume material. The ambience is being driven by a hypertexture. That's a phased hypertexture, and the rest of it's just working through the density and colour generated from this texture component, which is object space mapped. Its origin's been moved around a bit, so if we could set the origin as 0 for example, and we'll see different parts of this cloud, and it's scaled so we can shrink it down so we can see the entire thing, but you can see that its area of operation is only limited really, and I think that relates to the fact that it's based on one of the object central, well, image central distance origin type functions. Here we've got distance squared, there you go, and here we've got a distance origin, and here what have we got here? Some sort of fractal. So let us do away with a lot of this. In fact, we'll just take this and go to basic and load in something like this distance origin, and go to sort of first principles. So I'll just reset that filter there. So we've got noise, we've got phase, and we've got this function. So this function, if we make it one-dimensional and rotate it round, it's just like a flat surface. Now, so let's see if we can coax some kind of output out of this. Right, so it's symmetrical about the origin. So if I compress this down, you've got to imagine that underneath there is the other part of the stripe. So you can see this is the gap in the middle, which corresponds to this black area, and then the solid area, the white area, and the colours it's taken from top and bottom. So if we look at the alpha channel alone, which is determine its density, and put a sine function in here, we could arrange it so that we've got it hollow at the top and a stripe. We don't know what's happening underneath there. If we wanted to look underneath there, we could try and shift this with a phase function, or we can just look in this and see we've got, well, looks like two horizontal stripes. So continuing with this frequency increasing sine function, we can make it striped in layers, which is quite handy really, because it allows me to demonstrate some things about this function. But what I'm going to do is I'm going to reverse the sine function and try and get it so I've just got two layers to work with. So I've got a negative on the sine function there. So there's a main band and a tiny band across the middle, and then another main band. Bring the colours back in, you can see how these colours then apply to those layers. So if we made that one black where it's going to be brightest, we'll have solid stripes in there. So you can see now how this has created, well, something, maybe not something very useful, but it's created something to work with. And I'm looking right along the edge of it now, and then we can modify this. We could take the quality up, for example. Now these zones here, which are the stripe here, we can do banded. That will change the patterning, for example, so you can have more detail in there. Let's change this colour so we can have more striking colour. So we've added bands, and then we'll see how that's affected the appearance of this. Well, they've come out rather bright. You can just see the edge of that. If we want to lower that intensity, we can reduce the output of the hypertexture there, and we'll start to see the coloured bands as they appear in the initial material, and you can see how they're adding to the stars in the background. So let's take them up to a level where they're a bit brighter, and I'll show you how now a phase function can break this up. So we go to the phase for this component like so, and I'm going to put in a fractal, give it 4 octaves, set it up so it's 3D. Now if you'd imagine, say you're lying in bed and these are the sheets, so like sheet and a blanket, all different colours. The phase function is like you kicking it with your feet, if you like, and so you can't kick one blanket through the side of another, so they will always remain in this order, the layers, but the phase function can disrupt it to such a degree that you can no longer see that order. So as I add, oops, that phase is moving it down, so if I rotate this round so it's the other way up, because phase is like pushing, we're like pushing up with our feet, there you can see the effect of it. So if I increase the frequency of this, then I'll just take it up a bit, you can see they're just crumpling it up. So the idea is, if you just add not a huge amount, just right click, you can add one bit at a time, you can add a bit of fractal function to this, and hopefully it'll make it look a bit like a cloud. So that's the idea behind adding the fractal function, to break the surface up to give it a cloud-like form. So this, as I was explaining, is based at the moment just on a flat 1D surface. If we go to 2D, it becomes a cylinder, which, depending on where we position our camera, we'll be looking down that cylinder. So it's a rather strange effect, but if we can orientate it, and I can show you the inside of that cylinder. So that's a bit of a weird effect. That could be used, I suppose. We could go with this idea like so, create like a time tunnel. And the next stage from this, from the cylinder, is to go to 3 dimensions, and at that point it becomes a sphere that's made of concentric layers, and depending on the density of those layers will determine whether you can see inside them or not. So you get this sort of effect. This is very dependent then on the quality setting. If you set the quality right down, it becomes quite crude, and whichever way you look at it, it looks like a cylinder, because you're relying on the additive effect to show you what it looks like, and it's made up of so many slices. As you increase the quality to very high levels, it will slow the render time down, but it'll fill in that sphere. So the rendering of it, which is done in concentric circles, will match the shape inside, and that gives you your different effects. So there's that then is a guide, rather simplistic guide, I admit, to how these distance origin functions can be used to create nebula effects. Obviously I encourage you to take apart my scenes and my materials, pick them apart, try things out. So the thing to learn from this is that the phase function doesn't disrupt the order of the noise function. Only changing the noise function can do that. The phase function can only push it, like pushing on layers, even if they're 3-dimensional layers or 2-dimensional layers or 1-dimensional layers that are just like sheets. You can't push one through the other. It can only look like it's been pushed through, but you'll still find that in there somewhere will be the other layers that have been disrupted. If you want something that looks like clouds, then fractal is a good thing. You either use multifractal and very high frequencies, or just a standard blending modes there. But either way, fractal's a good one. About 4 octaves is usually enough, and fairly low levels of phase. So this is it with multifractal. So it's a bit more disrupted. It's quite exciting, really. I'm not sure about those colours, but there you go. we've still got our other things hidden in there in the background. I wonder what happens when I turn those on. So if I select all attributes, unhide them and unlock them, we'll see what effect these things have. So okay, that's my asteroid breaking through this cloud layer that have been created. So I'm going to make that a bit bigger. There we go. And then if I can move it away from the camera, which will be, if I choose camera space, here we go, and then work the direction out to move that sphere, we can have that effect like so, which is interesting if not necessarily that useful. I'm just not sure about the orange colour. So in the banded, here's where the colour is, so we can modify this colour. I don't know what I should have really. Maybe a light cyan, maybe that's too bright. Maybe if I make that one a really dark blue or greeny blue. Let's see, how's that look? Oh, quite like that. So there we go, we've got that effect, and because it's a volumetric material it can actually interact with this asteroid body. If you've got that happening, then the higher the resolution that you use, let's move the asteroid a little bit to one side so we can look down here. So the end of the tunnel, the higher resolution you use for the volumetric material in here, in this sphere material, this quality setting will improve its interaction with other objects. But you might find, because it's sampling more layers, you lose definition on the pattern, so it becomes a lot more subtle, in which case if it becomes too subtle, then you can do things like increase the alpha response. Now you can't modify the color response except using the filter in this component, but the alpha can be adjusted in the final combination. So if you go to, say, smooth clip and reset that, you can change this alpha, which is determining how solid it is. Now if you go for a very sharp transition on the smooth clip, pop the colors back, then you'll see sharper transitions in your final material, and so it'll put some of that detail back. So you can see now it's got these like sort of hard looking edges, which might be a nice effect or might be a bit extreme, because you can see the layering. If you want to lose that layering, then you can reduce the effect of this clipping somewhat, not make it so extreme. If you just turn the colour off, you can see the effect on the alpha. And the other thing you could do was increase the contrast here. Another way of getting a more layered effect. So I liked that green colour, so I'm going to go back to that. I like this green colour. So I can use HLS and just reduce the intensity and increase the saturation there. That should maintain my green colour somewhat, and then increase the quality, so that'll have the effect of softening the transitions. Even though we sharpen the transitions, we've got more contrast in the colours. I'll move this asteroid again a little bit to one side, leave the other things active. So there you go. I've very crudely and quickly generated a very simple sort of volumetric cloud effect, and showed you some of the things that impact on its appearance. But once you can make even a little bit of headway into experimenting with these volumetric materials and understand some of the principles, then you can build on that and come up with more complex effects. It's just a matter of layering effects in the deep texture editor, and then finally using the material components and the ability to blend channels in that, and you can create all kinds of sophisticated effects that have a very small memory footprint, but highly versatile and reusable in many other scenes. So once you've created one material, you can save it to the library or save it with an object, put it in the library and create more. So I hope that made some sense and will inspire you to experimenting with the volumetric materials. Okay then, cheers now.